Hello everybody, and welcome to the tutorial. Today we're going to import data into EEGLAB from the Muse EEG headset and create ERPs. So to get started, you're going to have MATLAB open and then go ahead and open EEGLAB. And now within EEGLAB, go ahead and go to Manage EEGLAB Extensions. And you're going to want to be sure that you have two required plugins for this tutorial. The first one is type in XDF up here, and you're going to want XDF import. And this is what's going to allow you to import the EEG data that you can download in the description. And the second plugin, of course, is just ERPLAB. So you just select it and hit install/update if you don't have it installed already. I already have it installed, so I'm going to go ahead and close out. And now I'm going to import the data for this tutorial. Again, you can download it in the description below. So what we're going to do is go to File, Import Data, using EEGLAB functions and plugins, and then do from.xdf or .xdfc file. So we're going to click there, and then we're going to locate the data that we downloaded. Go ahead and hit OK here, and I'm going to name it tutorial. So now it's imported. The first thing I'm going to do is delete unnecessary channels. So if I go to Edit and then select Data, you see channel range right here. You can hit this button to bring up the channels. So this fifth channel right here, right AUX, that's actually a channel if you add another electrode to the Muse. Which I don't have, so this channel is junk and I need to remove it, so I can select OK. And then right here, just select remove these, so it removes the channel, and then hit OK. It's going to ask us again where we want to download the data set. I'm just going to hit OK. So the data sets, it says whenever you make a big change. For example, I just deleted a channel there, and it allows you to revert back to a previous data set if you made a mistake. So say I deleted the wrong channel on accident, I can go to datasets, dataset 1, and you see it brings back all 5 channels. Now I can go back, and now I'm here after the channel's been removed. Next up, I'm going to get the channel locations. So I'm going to go to Edit, Channel Locations. Use this default option here, the M and I coordinates, and hit OK. And it should automatically fill out the channel locations for you. If it doesn't, you can click Look Up Locations right here, and it will fill in the blanks for you. So I'm going to hit OK. The next thing I'm going to do is just apply a bypass filter. So I'm going to go to Tools, Filter to Data, Basic FIR filter. And I'm going to filter out all ranges below 1 Hz and above 30 Hz. So low edge of the frequency passband 1, and then the higher edge 30. You can deselect this. You don't need to plot the frequency response. And just hit OK, and it's going to save you the new data set. So now we can move on to creating the ERPs. So we're going to go to ERPLAB, Event List, and create EEG event list. And it's going to give you a warning here saying that some of the events contain a text-based event label, not a numeric event code. I'll show you why this is important to keep in mind here. If we go to Edit, and then we do select data using events, and we look at our event types. You can see my event types start with the name of the event, like fixation onset, and then ends with the numeric code, 6. This is by design. Once we create the ERP events, it's going to remove everything to the left of the number. So I'm going to end up with our 1, 2, 3, 4, 5, 6, 7. And you'll see why this is important here in a minute. And just for reference, I'm going to create a screenshot that contains the name of my events before I do this change. So I'm going to put this to the side and cancel out of here, cancel here. So we're back to the create basic event list GUI. I'm going to go ahead and just hit create. It's going to want to save the new data set. I'm going to hit OK. And now if we go back and we select data using events, you can see all we have are the numbers themselves. So the next up is to assign the bins. So we go to ERPLAB and assign bins, bin lister. Now I will provide a link in the description to the bin file that I'm using. But I do want to show you a little bit how this works. If I open up the bin file, this is the name of the bin, bin 1. This is the label, non-target. And right here are these numbers that we had. So non-target is whenever we prevent stimulus that is not the target. This is an oddball task. So 80% of the stimulus is a non-target, and then 20% is the target. The target is a red oval where the subject is required to press spacebar to respond, whereas the non-target is just a blue rectangle. So we look at non-target, it starts at 3, which is non-target onset. This is when the non-target is displayed. And then we want to go to 7, which is the gray screen onset. The gray screen is what always follows the target and non-target, right? So we're going to have non-target 3 to 7. So target would actually be whenever the target is displayed, there's an onset, but the subject does not respond like they should. A lot of times this bin is actually going to be empty, but I keep it just in case we have some bins where the target was displayed and the subject didn't respond. But the vast majority of the target responses go in bin 3. You'll see here dot 4 and 5. This is when the target is displayed and then the subject responds. So this is going to create epochs, which are basically units of time, segments of time, when the target is displayed and then the subject responds. So these epochs actually start when the target is displayed. And the epochs within bin 3 are only when the subject responds, which is 5. So we're going to take this text file and we're going to select it up here. We're going to load it in. And you see I got oddball bins.txt. And then we can go ahead and run this. And then hit OK. Now what we need to do is extract bin-based epochs. So what this is going to do is it's going to take our bins that we created and actually extract the epochs, which are segments of time. I'm going to go with negative 200 milliseconds to 800 milliseconds. So what this means is, say, non-target. Whenever a non-target is displayed, and only when it is followed by the gray screen, which it always will, the very onset of the non-target, the blue rectangle, our epoch is going to start 200 milliseconds before and go up to 800 milliseconds afterwards. I'm going to put none on the baseline correction here because we can actually apply that whenever we go to display the ERPs. So I'm going to go ahead and hit run here. It's going to save a new data set. I'm going to hit OK. You'll see here we now have 200 epochs. Next up, what we're going to do is we need to delete any epochs where there's like an eye blink or some noise. So to do that, we can go to Artifact Detection and Epoch Data, and we're going to do a moving window peak-to-peak threshold. Usually the default settings work pretty well, and that's what we're going to use for this tutorial. Hit accept, and it's going to want to save the new data set. And before we do that, we can actually scroll the data itself and see what's being removed. So if we hit normalize, what is selected in yellow are the epochs to be removed. So this right here, for example, is an epoch, right? So you have our non-target bin 1 right here. And we can go through this data and look for whenever there's an abnormally large amount of noise. And most of it's already going to be pre-selected. Right here is a big eye blink. Same thing here. Looks like we could remove these as well. Right here, they're already selected. So I'm going to go ahead and hit update marks. This is clearly not a thorough analysis of the data, but for the purpose of this tutorial, it shows you how to check which epochs are being selected for removal. We're going to hit update marks. OK. Save the data set. And now we need to compute the average ERPs. So we go to ERPLAB and compute average ERPs. And we're going to exclude epochs marked during artifact detection, which is what we just did. We detected the artifacts and removed them. So this makes it so whenever we average our ERP itself, the data that we selected is properly rejected. It's not averaged in. So we're just going to hit run here. And we're going to have to give it a name. So I'm going to name mine ERP Tutorial 1. Hit OK. And one last thing we're going to do is apply a filter so the data looks a lot more clean. You go to Filters and Frequency Tools and Filter for ERP data. And if you go to Import Settings, you can select the filter that I put linked in the description to download. It'll load it in. I already had it imported, which is why you see no change on the screen here. Go ahead and hit apply. And I'm going to name this ERP21_F for filtered. Hit OK. And now finally we can go to ERPLAB, plot our ERPs, and then plot ERP waveform. And I'm going to do a baseline correction of pre, which is that previous, negative 200 milliseconds. I'm going to only do it for all channels. And I don't think there's any bin 2s, but we'll see when we run the plot. So we'll plot the data. And how this is set up is the Non-target is the black line, so this is the blue rectangle, and then target response is the blue line, which is whenever the subject had a red oval and then they hit space. So there were no epochs whenever the target, the red oval, was displayed and the subject did not respond, which is why we just have a flat red line. And if we look here, it will appear to be incorrect, right? So TP9 and TP10 actually appear to be upside down. We should have a P300, but it's actually looking like an N300. So what happens is on the Muse, the amplitude is actually flipped upside down, because FPZ there at the front is used as the reference. So any electrical data reaching FPZ is going to be projected negatively to the other electrodes, since the voltage is the difference between the reference and the selected. So we're going to go to plot ERP waveforms. I'm going to just select the bins that I know I have data in, non-target and target response. And then we can hit positive is up, and we can change it negative is up, right? So we make that change here. Go ahead and hit plot. And this data is looking a lot better here. So what we have is red for the target response and then black for the non-target. And this is an oddball task, and as expected, we have a strong P300 at TP9 as well as TP10. You can kind of see it at AF7, but not really AF8. And the reason for this is that AF7 and AF8, those frontal electrodes on the Muse, are so close to the reference FPZ that there's not much of a difference between voltage or electrical activity reaching each electrode. So it's really hard to get ERP data on those two frontal channels, AF7 and AF8. But as you can see clearly at TP9 and TP10, the channels that are behind the ears here, we have a very prominent P300 during the target response, as we would expect with an oddball task. And that will conclude today's tutorial. Thank you for watching.